Hello, everyone. This lecture is about another law in trigonometry known as the cosine law. Cosine law is a tool that we can use to solve a variety of triangles. And in fact, when SOHCAHTOA doesn't work and when sine law doesn't work and we have no other tool to use to solve our trigonometry problem, that's when sometimes cosine law becomes very handy. The formula is just like this: a squared equals b squared plus c squared minus 2bc cosine of a. The proof of the formula, we're going to omit it for now, but it can be found in the textbook. You can just read it. It's optional. But it is a formula that relates the three sides of a triangle with one of the angles in the triangle. And here we have an example where two sides are given. Side A is 16, side A is 20, side C is 16, and the contained angle in between is 52 degrees. So what is given is two sides and one contained angle. And we want to find the opposite side of angle B, that is side B. So in order to find side B, we need to use this formula. But as you see, this formula is useful to if you want to find side A, right? Because it's just a squared equals the rest. It will be hard if you wanted to solve for B. Besides angle A must be given in order to use this formula. But here we don't have angle A, we have angle B. So that means that this formula has to be used by a little bit of modification. So what does that modification mean? We just have to adjust the letters, okay? Because cosine law is used when you have one angle, okay, and two sides. Side B is given, side C is given, and the contained angle in between is also given. So when we have this situation, we can find side A opposite angle A. But here, the letters are sort of messed up. So instead of finding angle A, we want to find angle B, all right? Not finding angle B. Instead of angle A being given, angle B is given this time. And instead of finding side A, side B needs to be found, basically. So we just have to adjust the letters. In order to adjust the letters, we can use this magic circle right here. So you can tailor this formula, this cosine law, for your need, and you can tailor it for your diagram. Letters A changes to B, B to C, and C back again to A. And this way, by this rotation of the letters, you can generate different forms of cosine. So I wrote here A squared equals B squared plus C squared minus 2BC cos A. That's the master formula. That's the cosine law. Now, if instead of side A, you're trying to find side B, as I'm supposed to do here, but in that case, change letter A to B using the magic circle. So A changes to B, B changes to C, C changes back again to A. Then B to C, C to A, and A to B. And this way, by using that magic circle and just the rotation of the letters, you can easily write the cosine law tailored for your need. So here, by using this second formula here, you can find side B. This is not a different cosine law. We don't have 10 different cosine laws. We only have one cosine law. But that cosine law could be tailored matching the letters that you are looking for in your diagram in particular. So let's say you're looking for side C in some diagram. So in that case, B changes to C, C changes to A changes back to B, and then B changes to C. And you see that you can write a formula for C squared from where you can find side C. So it's not like always they ask you to find side A. Maybe they ask you to find side B. Maybe they ask you to find side C. So you have to see how the letters work. Use the magic circle, tailor the cosine law formula to your need, basically. Okay? So here, that's what I have to do. So I'm going to start with B squared instead of starting with A squared. Okay? And I'm going to use the second formula, which is tailored for my need. So I'm going to say B squared equals A squared, which is 20 squared. C is 16 squared minus 2 times 20 times 16 times cosine of 52 degrees. Okay, so now I have to use a calculator to find this answer. Now, what I want you to do is to find the answer in one shot. Okay, I've seen many students who are still in the mood of elementary school. They calculate 20 squared separately, that's 400. 16 squared separately, that's 256. And then one by one, little by little, they find these, and then they sit down, and then they take their time, they add them up, and then again simplify. And after 5 lines, they get the final answer. That's in elementary school. In high school, we do this in one shot. Otherwise, why are we using calculators? We are using calculators to find the answer not only accurately, but also very quickly. So we have to use our calculators efficiently. So I'm going to input this whole thing in one shot. So I'm going to go 20 squared. You can also do it with me. 20 squared plus 16 squared. And then minus 2 times 20 times 16 times cosine of 52. All in one shot I punch in equals, boom, I got the answer. This is efficiency. This is the use of calculator in an efficient way, okay? So I got 261.9766. Now you take the square root to find b. So square root of this number, just one button. You press the square root button and you get the answer, which is 16.2. Okay, 16.2 is rounded to the nearest tenth of a unit. So units are not given, so I'm not going to write centimeters or meters. I just write units. And that is how I found side B. 16.2 is the length of side B, which was the unknown. How did I find this? I used cosine law, okay? Did I use the master formula for cosine law? No, I didn't. Why? Because I was not looking for side A. I was looking for side B. So what was I supposed to do? I was supposed to tailor it to my need here. In this next exercise, instead of having 2 sides and 1 contained angle, this time we have all 3 sides actually, okay? So we are looking for angle A. All 3 sides are given. We don't want to find any sides. But what is not given is none of the angles are given. So we want to find the measure of angle A. So we can still use cosine law because think about it. A, B, C are known. Angle A is unknown. But the thing is that when you want to plug in numbers here and solve for cos A, it will be very messy in terms of the algebraic manipulations that you have to do. So it is better to do this manipulation ahead of time and come up with a clear-cut formula that we can easily plug in numbers and find the answers. And that is what I have already done here. So if you, for instance, grab this term and transpose it to the other side, it becomes positive. And if you transpose a squared from left side to right side of the equation, it becomes negative a squared. So you end up with b squared plus c squared minus a squared on the right-hand side. And on the left-hand side, you have 2bc cos a. So by dividing two sides by 2bc, you're solving actually for cos of a. And this is a clear-cut formula because you have all 3 sides, and all you have to do is just plug in for ABC, and boom, you get the answer for cosine of a in one shot. And as I said again, using the magic circle, you can switch the letters A to B, B to C, and tailor this form of the cosine law to your need. If you are looking for angle B, you can use cos of B equals to this formula. If you're looking for angle C, you can use this formula, cos of C equals that fraction. And just like before, B changes to C, C to A to B. In the bottom, 2BC becomes actually 2CA, all right? And angle A changes to B, and there you go. That's the formula for cosine of B if you're looking for angle B. So here I'm looking for angle A, so I'm going to use the first formula, okay? So I'm going to go cos A equals B squared plus C squared minus A squared over 2BC. In the next shot, I'm going to plug in the numbers. B is 38, so 38 squared plus 26 squared minus 30 squared over 2 times 38 times 26. Now here, many students are making mistakes because when they use the calculator, they don't pay attention to the fact that calculators work based on dead mass. And if you punch in the buttons incorrectly, you get incorrect answers. Okay, so you have to make sure that the whole numerator is being divided by the whole denominator. And that's why I suggest, I suggest that before you punch in anything, you open a big bracket and then punch in the whole numerator and then close the bracket. Then you press the division button on the calculator and then you open another bracket and then you punch in the whole denominator and then you're gonna close the bracket just like that. This way, your calculator is going to follow the bed mass and you will get the right answer. You would not be confused. You would not be discouraged getting all these wrong answers. And you will divide the whole numerator by the whole denominator, getting an answer less than 1. Okay? We used to do this experiment in the class, and students would come up with like 12, 15 different answers for one, simple calculation. So we're going to do that right now. So 38 squared plus 26 squared minus 30 squared. The whole thing divided by 2 times 38 times 26. I'm dividing the whole numerator by the whole denominator, and I'm getting a decimal answer. So 0.6174089069. That's what I got. So angle A would be inverse cosine of this figure. You can just use 4 digits after decimal point, or like 5, 6, or the whole thing. It doesn't matter. But at least 4 digits after decimal point needs to be used. And now you press the inverse cosine button on the calculator. And the answer will be 51.8 degrees. Of course, you can round it to the nearest degree, as always we do. So 52 degrees. So we were supposed to find the measure of angle A, and we did use cosine law, and we found the measure of angle A, that's 52 degrees. You can use it again to find angle B, for example, okay? And then you can add them up, subtract from 180, find the measure of angle C, for example. You can even solve this triangle if you want. So 2 forms of cosine law. This one is useful when you are looking for a side length. The other one is useful when you're looking for an angle, like my second example. And if the letters are not matching with the master formula, it is okay. You can use the magic circle, switch the letters A to B, B to C, C to A, and this way you can tailor the formula. You can tailor cosine law for your own need, okay? And this way you can solve many trigonometry problems, okay? So keep practicing, and I think we're going to be doing one more lecture on the applications of cosine. Thank you.